Welcome and thank you for joining me. We're about to start lesson U2A6, where we will go over the intersection of a line with a plane. Before we get started, I would suggest that you have a piece of paper and a pencil ready so that you can follow through each and every case of how a line intersects a plane. So here we have a plane and a line is going through the plane, which means that the line and a plane may have one intersection point. Case number 2, the line may be parallel to the plane, which means that there will be no points of intersection. And case number 3 is when the line lies flat on the plane, which means that there will be an infinite number of intersection points. So we're going to take a look at an algebraic example for each case so that we can connect the algebraic solutions or explanations to each and every case that we describe. In example number 1, we are given a line L with equation r equals 312 plus s1 negative 4 negative 8 and a plane pi with equation 4x plus 2y minus z minus 8 equals 0. So the line is given in vector form and the plane is given in scalar form. Now remember that any point on this line can intersect the plane. So in order to find out what that point is, we will first have to derive the coordinates of any point on this line. Remember that this equation can be written as x, y, z. So these are the coordinates of any point or the head of the vector r, which is on this line, equals the starting vector 3, 1, 2 plus s, coordinates of the direction vector 1, negative 4, negative 8. So let's develop an equation for each parameter. So we have x equals 3 plus 1s. So x is 3 plus 1s. We have y equals, so here is y, 1 minus 4s, well, plus negative 4s. So 1 minus 4s, and z is 2 plus negative 8s. So z equals 2 minus 8s. Now we're going to say that this point will be on this plane if the coordinates will satisfy x, y, and z, will satisfy the equation. So for this, we are going to substitute 3 plus 1s for x, 1 minus 4s for y, and 2 minus 8s for z. So we have 4, 3 plus 1s, plus 2, 1 minus 4s, minus z, 2 minus 8s, and then minus 8 equals 0. If we're able to find the value of s that satisfies this equation, then we'll say that we'll be able to find the x, the y, and the z coordinates of a point of intersection. So let's solve this equation. Again, it's a simple linear equation, so we go 4 times 3, 12, 4 times 1, 4s here, plus 2 minus 8s, minus 2 plus 8s, minus 8 equals 0. Let's collect like terms, and we'll have here 4s, negative 8s, positive 8s, so we have 4s equals, so we have 12 plus 2, 14, minus 2, 10, minus 2, 12 minus 8 is 4. So s equals 1. So we'll say that since we found the value of s, we can derive the coordinates for the point. So we have 3 plus 1 times 1, that's a 4. Y will be 1 minus 4 times 1, that's a negative 3. And z equals 2 minus 8 times 1, which is negative 6. Therefore, we're going to say that the point of intersection will have the coordinates for negative 3 and negative 6, and yes, the line will intersect the plane at a point. In the next example, we have to find the intersection point made between the line given in parametric form, and the plane here, which is given in scalar form. So similar to the previous example, we are substituting the coordinates of x, y, and z into the equation of the plane. So for x, here we're going to have 2 times, so x is 2 plus t, minus 5, this 5 here, and then we have to substitute the y coordinate this time, 2 plus 2t, plus z, so here is z, 9 plus 8t, and then minus 6 equals 0. So let's solve this equation. We have 4 plus 2t minus 10 minus 10t plus 9 plus 8t minus 6 equals 0. Let's calculate terms. So we have 2t minus 10t plus 8t. So that makes 0t. 2 minus 8 plus minus 10 plus 8 equals 0. And that would equal, so here are the constants, 4 minus 10, that's a negative 6. Another negative 6 will make a negative 12. Negative 12 plus 9, negative 3. So take to the other side, positive 3. So the value of t would be 3 over 0, and this is undefined. And the fact that the t value is undefined tells us that it is impossible to find a t value that can help us find the coordinates of each point, so each coordinate of the point, so the x, the y, and the z. So if it is impossible to find the coordinates x, y, and z of the point of intersection, it means that the point of intersection doesn't exist. And that tells us that the line L would be parallel to the plane pi. So moving on to example 3. This time we have the equation of a line given in vector form and the equation of the plane in scalar form. So we'll derive the parametric equations for the line R. So remember that we have x, y, z equals 3, 2, negative 1 plus s, 14, negative 5, negative 3. So the parameter x will have the equation 3 plus 14s. Parameter y is 2 minus 5s. And parameter z is negative 1 minus 3s. With these 3 coordinates, we are going to move on to the equation of the plane x plus y plus 3z minus 4 equals 0. Substitute the respective x, y, and z values into the equation. And then we'll have for x 3 plus 14s, for y 2 minus 5s, and then we have 3z, so 3 negative 1 minus 3s equals 0. So let's simplify. Minus 3 plus 9s equals 0. Calculate terms. So we have 14s, negative 5, and negative 19s. Negative 9s. So that will give 0s equals, and here we have positive 3, positive 2, and then negative 3. So in this case, we'll have 5 minus 3, 2 plus 2, 4, and then minus 4, that is 0.